Good morning, student. Okay, I hope you understand metallurgy chapter and you have done all the question answer which I have gave you yesterday. So with that, all the question answer are very important for exam point of view. Anyhow, from this question only some question will come definitely. So those who did not have done, please you have to do that question answer. Okay, you will find out answer from textbook, or if you can't able to find out, then you can ask me anytime. Okay, now next chapter, that is chapter number 7, which is called a hydrogen chloride gas and hydrochloric acid. So first we'll take introduction. What is hydrogen chloride gas? So the first prepared by this hydrogen chloride gas is a Glaber. This scientist first react a common salt or rock salt with the concentrated HCl, and he found HCl plus Na2SO4. He found that HCl, but he cannot able to recognize that, so that HCl. So that's why he cannot able to give the name of this component. He found that the something is observed and something is present after this reaction with the common rock salt with concentrated HCl, but he did not able to find out the what type of gas is produced, that he cannot able to find out. So after that, Joseph Priestley prepared it by the same method. He took a same NaCl, rock salt, which means NaCl plus concentrated H2SO4 by the same method, and they collect the HCl gas over the mercury in a pure and dry form. Collect the HCl gas over the mercury, which means that he took a mercury in a liquid form, so mercury, and when the gas is influenced by this reaction, so that gas he collect over the mercury in a pure and dry form. So he found that okay, particular gas I collected, and that gas he named a marine acid. Marine acid because it is formed from the rock salt or common salt, so that's why he told that a marine acid. Okay, so then afterward, one of the scientists, Lavoisier, he gave this name a muriatic acid. Muriatic acid, not muriatic, muriatic acid. He gave the name it. Okay, so here the first a Glaber, he react sodium chloride and concentrated acid. He found that something gas, some gas is producing, but he did not know about that. Then Joseph Priestley done same way, and he got a particular gas, and that gas he named a marine acid. Why acid he gave? He done some experiment over the that gas. So by litmus paper and some other way he done that experiment, and then he found that that particular gas is acid, so he gave a name of marine acid. And then after that, Sir Humphrey Davy proved it that that particular this muriatic acid have a hydrogen and chlorine present in it. So he told that that muriatic acid is a compound which have a hydrogen and chlorine present in it. So that's why he gave a name it a hydrogen chloride gas in a water. He named it a hydrogen chloride gas in a water. Okay, so this is the history behind it. Now occurrence. In occurrence, he told that HCl gas are found in a free state. Occurrence, in occurrence, how it will found in a natural way. So the HCl gas are found in a free state in the gas given out by the volcanoes. So when the volcanoes are coming out, so at that time the numbers of things are coming out. So gas also coming out. So in near to the surrounded of the volcanoes, HCl gas is present in that atmosphere in a free state. It is also present in a gastric juice as a aqueous solution. Gastric juice, which means that that juice or that acid is secreted by the animal stomach. So in our stomach or in animal stomach, the food is digested by the acid. So that gastric acid also, in that gastric acid, the HCl also present, very little amount. Okay, then we'll learn the general preparation method. General preparation method, that is a direct combination method, we can say a direct combination method. So the equal volume of H2, equal volume, which means that suppose a 1%, 50% of H2, then 50% of Cl2. So the equal amount, equal volume of the H2 gas and Cl2 gas is combined together. So they both are diffused with each other in presence of sunlight, and it will form twice HCl. It will form HCl gas. Okay, equal volume of H2 plus equal volume of Cl2, both of them diffuse with each other in presence of sunlight and form HCl gas. Okay, and second, a burning of the hydrogen gas direct in a chlorine gas atmosphere, which means that a chlorine cloud if present in the atmosphere, then from the in the chlorine cloud, if the hydrogen gas burn, then in atmosphere HCl gas will be produced. So these are the general preparation method, or we can say a direct combination with H2 and Cl2. Direct combination, both of them directly combine hydrogen and chlorine and form a HCl. So that is why it is known as both the reaction known as a direct combination reaction, a direct combination reaction for preparation of HCl. Okay, I hope you clear about it. Now the next point, that is a laboratory preparation. Next point is a laboratory preparation of the HCl. Very important point, exam point of view, so many questions asked in it. So that's why I am telling you, you just concentrate here. Okay, whatever I told you before, all these things are a general thing and the introduction only. But the main thing of the chapter is start from here. So many questions, numbers of questions will ask from this in this topic. So just pay attention here, student. So the laboratory preparation. First, when we prepare some chemical in a laboratory, so we use a reactant to react together. Okay, so what we are preparing? We are preparing HCl. So in preparation of the HCl in laboratory, first they took NaCl as a reactant. First they took NaCl and concentrated H2SO4. Why NaCl? So why NaCl? Just remember, student, why NaCl? They use NaCl. So first question, why NaCl used as a reactant in laboratory preparation? So first, it is easily available, and second one, it is very cheap in a cost. So that's why it is very convenient to react. This NaCl is very convenient, so that's why it is took as a reactant. Okay. Second, why concentrated H2SO4? Why not HNO3? So first thing, that HCl, concentrated HCl is a non-volatile substance. Non-volatile substance, which means that by particular temperature we are using in this reaction. When NaCl and H2SO4 react together, we apply some heat. When some temperature we will apply it. So at that time, whatever the concentrated H2SO4 is used, and if it is volatile, if the other substance is there, suppose HNO3 if we take, HNO3 is also acid, concentrated HNO3 if we take, then HNO3 is a volatile substance. And if we take a volatile, when we heat it, so it convert into the vapor. But concentrated H2SO4, it cannot able to convert into the water at higher temperature even, because it is non-volatile. Volatile, you know very well what is the meaning of volatile. So the non-volatile substance. That's why first and most important, concentrated H2SO4. Why not concentrated HNO3? Concentrated HNO3 is a volatile substance, and the concentrated H2SO4 is a non-volatile substance. And at higher boiling point, it can easily display a volatile HCl solution. 2 point, very important. Why concentrated H2SO4 is taken in laboratory preparation? So the first point, it is non-volatile. A second point, it have a higher boiling point and can display easily volatile HCl gas. Is it clear? Have you understand this? Okay. So these are the first reactant which we took. Why this reactant we took, that also I explained. Now the condition for that. Condition is that the reactant heated below 200 degree centigrade. Very important, student, below 200 centigrade. In your textbook it is given it should not be heated above 200 degree centigrade. That type of thing is written. What is written? It should not heated above 200 degree centigrade. This is about 200 degree centigrade. Or I just wrote that heated below 200 degree. Below 200 degree centigrade, which means that not 0, okay, 180 or 190 or around like that, approximate, but it have to be below 200 degree centigrade. Got it? Understood? So now first we'll see why below 200, that also I will tell you. That also important question, but first we'll see that when NaCl react with the concentrated H2SO4 at below 200 degree centigrade temperature, it will form HCl gas and sodium bisulfate, sodium hydrogen sulfate, okay, sodium hydrogen sulfate. Sodium hydrogen sulfate will be formed. Okay, this sodium hydrogen sulfate will be. Now the main question, that why below, why not above? So if we take a above 200 degree centigrade temperature, if we take NaCl and concentrated H2SO4, it will form a 2HCl gas, more than that, and instead of the sodium hydrogen sulfate, it will form a sodium sulfate, Na2SO4, sodium sulfate. Now this sodium sulfate is present as a solid form, fused state, it will fuse into the glass apparatus, it will fuse, which means that very sticky, it will stick on a glass apparatus in a solid form, and if it is stick on it, then it is very hard to remove it. So then that glass apparatus we cannot use further. So that is why we are not heating at higher temperature. Second point, if we heat higher temperature, then there is a chance to crack a glass apparatus. So maybe apparatus cracked due to the high temperature. Got it? And the third point also, this is not given in your textbook, but if we can get the HCl at below 200 degree centigrade, then why we are taking the above 200 degree centigrade temperature? So we can here, if we take a 200, more than 200 degree centigrade, then there is a loss of energy. So there is also there. So the loss of energy, we don't need it. So there are 3 points, very important. In so many time in exam ask, in previous year exam asked this question, why reactant of NaCl and concentrated H2SO4 in laboratory preparation heated below 200 degree centigrade. So the reason is that you have to write this equation. When we heat above 200 degree centigrade NaCl and H2SO4, it will form sodium sulfate, and the sodium sulfate display in a solid state and fuse in a glass apparatus. So the further reaction that glass apparatus cannot use. For the further reaction that glass apparatus cannot use, and may apparatus crack due to high temperature. And the third point, loss of energy. We are losing energy because the lower temperature we are getting HCl gas, then why we are using the higher temperature? So that is, we can say that a loss of the energy. It is not good. Okay, you got my point. Very important. 2 questions we learn from this. Reactant, which reactant we use and why. Second point, we are heating this reaction at below 200 degree centigrade temperature, not more than, and why below, not higher. So reason we learn. I hope you clear about it. Okay, so till here I explain you the apparatus, how it's arranged. So I'll explain you in your textbook. Here the method. So this is the round bottom flask. This is a round bottom flask. In round bottom flask, this is threshold funnel. Now here this you can see this small pebbles, like this is the rock salt or NaCl, and a threshold funnel is used directly to add a concentrated H2SO4. To add concentrated H2SO4 directly to the NaCl, that's why this threshold funnel is used. Okay, and heated. Now this solution is heated. Now heated, here this round bottom flask is connected with the another conical flask. This conical flask is heated, filled by the concentrated H2SO4. This is filled by the concentrated H2SO4. Why concentrated H2SO4? That I am telling you. So that also I will tell. So this concentrated H2SO4, now here the HCl is generated, that HCl vapor, moist HCl. Why moist HCl? Because here the NaCl and we are adding H2SO4. So H2SO4 have a somewhat amount of the water present in it. H2SO4 and somewhat amount of the H2SO4 is present in H2O present in a H2SO4. So that's why that H2O is in vapor form, which is already present in it. So with HCl, that H2O vapor also there. So we can say that the moist HCl gas. We can say moist HCl gas is transferred. I repeat one more time. When we are adding concentrated H2SO4, a little bit amount of the water present in it, because 98% H2SO4, concentrated H2SO4, which means 98%. So 2% water present in it. So that 2% water present in it, which at this much of temperature it is present here in vapor form. So when the HCl gas produced, it will transfer with the HCl gas. Water vapor is transfer with the HCl gas. That's why it is a transfer here. Here it is mentioned the moist HCl gas. So that moist HCl gas is transferred here in concentrated H2SO4. And from here this water concentrated H2SO4 through that, here the till here we have you understand? Till here you understand. Okay, now we are filling in this concentrated H2SO4. So why concentrated H2SO4? So let's learn the why concentrated H2SO4 we are taking in it. So concentrated H2SO4 is behave as a drying agent. Concentrated H2SO4 is a behave as a drying agent. Drying agent, which means that whatever amount of the water present in a gas, this concentrated H2SO4 is absorb it and make it dry. So with a moist HCl have a water vapor present in it. So this concentrated H2SO4 is behave as a drying agent and they absorb water from it, and then this dry HCl is formed. Dry HCl is formed. So we can say the concentrated H2SO4 is a drying agent. Okay, and also we can say that this concentrated H2SO4 is a dehydrating agent also. Dehydrating agent. There is a difference between dehydrating agent and drying agent. It is behave like both the way, drying agent and dehydrating agent. Now dehydrating, you know, dehydrating agent, which means that it can absorb water, and here drying agent, which means it can absorb water. But what is the difference between it? For example, I have a C2H5OH alcohol. Now alcohol is passed through the concentrated H2SO4. So this H2SO4 dehydrate alcohol and it convert into the C2H4 plus H2O. It is not given in your textbook, but you have to learn about this. C2H5 alcohol. So in alcohol, one hydrogen from here and OH. So C2H4 and H2O. So from the substance hydrogen is absorbed, that is called dehydrating agent. From the substance, from the inner side of the substance, water molecular is taking out, which is called dehydrating agent. And drying agent, which means that HCl have a moisture with it. This is the vapor, moisture. It is not bonded with the HCl, but it is present with it. So that H2O is taking out by the H2SO4. So concentrated H2SO4 is a behave like a drying agent as well as dehydrating agent. But here what is the important part? The important part is here in this laboratory preparation, the concentrated H2SO4 is a behave as a drying agent to absorb the moisture from the moist HCl and make it dry HCl. And the dry HCl here, the dry HCl is taking out from here and it will transfer in this upward displacement of the air, here glass jar. Okay, I hope you understand till here. Other queries if you have, then I will further explain about this and what is the precaution we have to take. Some other example also are there, other drying agent also are there, but why we are not using that other drying agent, everything we will learn in a next class. I hope you understand till here. If you find any difficulty, you can ask me after this video. Thank you.